Observability and SRE Part 7. This episode has 13 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. Secrets migration. How would you migrate applications from mounted JSON service account keys to workload identity and secret manager? Here's a strong way to approach it. Enable workload identity on the cluster and node pools. Create the IAM binding mapping each Kubernetes service account to its GCP service account, and update application deployments to use that KSA instead of a mounted key volume. Test in a non-production namespace first since the change is transparent to most client libraries. Once verified, disable and eventually delete the old JSON keys, and migrate any application secrets, not just GCP credentials, from environment variables or config maps into secret manager accessed via the same workload identity. Nice. Let's continue. Question 2. Landing zone. How would you design a GCP landing zone for a product company, including org hierarchy, folders, projects, shared VPC, IAM, org policies, logging, and billing? Here's a strong way to approach it. Structure folders by environment or business unit, e.g. prod or non-prod at the top level, then team folders beneath, with one project per workload or environment combination rather than shared projects that mix concerns. Centralize networking via shared VPC from a host project, enforce guardrails with org policies, restrict public IPs, require OS login, restrict resource locations, aggregate logs and billing to dedicated projects, and grant IAM at the folder level where possible so new projects inherit consistent governance automatically. Great. Moving on. Question 3. FinOps. A monthly GCP bill increased by 40% after a platform migration. How would you investigate and reduce cost without harming reliability? Here's a strong way to approach it. Break down the billing export by project, service, and SKU to find exactly what grew, and compare against what changed in the migration. New resource types, higher replica counts, a different machine family, egress traffic patterns. Common culprits are unoptimized machine types, missing auto-scaling limits, or unexpected cross-region or cross-zone egress. Address the specific driver, right-sizing, committed use discounts, reducing egress, rather than broadly cutting resources, and validate reliability metrics didn't regress after each cost change. Alright, next question. Question 4. DR or backup. How would you define RTO and RPO for a critical service on GCP, and how would you test backup, restore, and regional failover? Here's a strong way to approach it. Define RTO, how long the business can tolerate the service being down, and RPO, how much data loss is acceptable based on business impact, not technical convenience. Then design backup frequency and failover architecture to meet those targets. A 5-minute RPO requires continuous replication, not nightly backups. Test regularly with real restore drills and full regional failover game days, not just backup completed checks, since an untested backup is not a proven recovery capability. Let's keep going. Question 5. Multi-region design. You have a multi-region reliability requirement on GCP. How would you design traffic routing, data stores, failover, monitoring, and incident response? Here's a strong way to approach it. Use a global load balancer with health checks to route traffic to the nearest healthy region, and choose data stores with multi-region replication, spanner, or a primary or replica setup with documented failover for Cloud SQL, matched to your consistency requirements. Automate failover detection and traffic shifting where possible rather than relying on manual DNS changes, and ensure monitoring and incident response playbooks explicitly cover the multi-region failure scenario, not just single-instance failures. On to the next one. Question 6. Platform maturity. How would you evaluate whether a platform is mature enough for product company scale across reliability, security, cost, developer experience, and automation? Here's a strong way to approach it. Assess each dimension against concrete signals rather than opinion. Reliability, slows defined and met. Incident frequency trending down. Security, baseline controls enforced by policy not convention. Findings tracked to closure. Cost, Visibility and accountability per team, not just a total bill. Developer experience, time from idea to production, self-service adoption rate, and automation, percentage of provisioning that's self-service versus ticket-driven. A mature platform has measurable answers to all 5, not just anecdotes. Good. Here's another one. Question 7. Gateway or API strategy. How would you choose between ingress, gateway API, service mesh, load balancers, and API for different traffic management requirements? Here's a strong way to approach it. Use ingress or the newer gateway API for straightforward HTTP routing into the cluster. Gateway API is the forward-looking choice since it's more expressive and vendor-neutral for advanced routing. Add a service mesh only when you need MTLS and traffic control between services inside the cluster, not just at the edge. Reserve API for external-facing API management needs. Rate limiting, API keys, monetization, developer portals that go beyond simple traffic routing. Nice. Let's continue. Question 8. MLOps lifecycle. How would you design MLflow or Vertex AI model lifecycle management with approval, deployment, monitoring, drift detection, and rollback? Here's a strong way to approach it. Track every training run's parameters, metrics, and artifacts in MLflow or Vertex experiments. Register a model version only after it passes evaluation gates, and require an explicit approval step. Automated threshold check or human review before promotion to production. Deploy behind a versioned endpoint so rollback is a config change. Monitor prediction distributions for drift against the training baseline, and trigger a defined response, alert, retrain, rollback, rather than letting drift silently degrade accuracy. Great. Moving on. Question 9. GPU workloads. How would you schedule GPU workloads on GKE with taints, tolerations, node pools, quotas, cost controls, and observability? Here's a strong way to approach it. Create a dedicated GPU node pool tainted so only GPU requesting pods schedule there, and add matching tolerations plus resource requests, NVIDIA.com or GPU on those workloads. Use quotas to prevent runaway GPU consumption by any one team. Prefer spot or preemptible GPU nodes for fault-tolerant batch workloads to cut costs significantly, and monitor GPU utilization, not just pod scheduling, since idle but allocated GPUs are a common silent cost leak. Alright, next question. Question 10. Cloud SQL Backup Restore. A Cloud SQL instance has accidental data deletion. How would you validate backups? Point-in-time recovery, restore testing, application cutover, and communication. Here's a strong way to approach it. Confirm point-in-time recovery is enabled and identify the exact timestamp just before the deletion occurred, then restore to a new instance. Never overwrite the original, so you can validate data integrity before committing to a cutover. Test the restored instance against a read-only query set to confirm the data is correct. Plan the application cutover, connection string change, brief maintenance window carefully, and communicate the incident timeline and data loss window transparently to affected stakeholders. Let's keep going. Question 11. Regional failover drill. How would you plan and run a failover game day for a GKE service with Cloud SQL, pub or sub, load balancing, DNS, and observability? Here's a strong way to approach it. Define the failure scenario precisely. Full region outage. Set clear success criteria, RTO or RPO targets, which alerts should fire, and run it in a controlled window with stakeholders aware, ideally starting in staging before production. Execute the failover procedure exactly as documented, not from memory. Measure actual time to recovery against target. Verify data consistency in the failed over Cloud SQL or pub or sub state, and capture gaps in the runbook or tooling to fix before the next drill. On to the next one. Question 12. GKE private cluster. A private GKE cluster cannot pull images or reach Google APIs. How would you debug private nodes, NAT, private Google access, DNS, routes, and firewall rules? Here's a strong way to approach it. Verify private Google access is enabled on the subnet, required for private nodes to reach Google APIs without a public IP, and check that Cloud NAT is configured if nodes need general internet egress for non-Google endpoints. Confirm dnsresolves.googleapis.com correctly. Private googleapis.com or restricted googleapis.com depending on config. Check firewall rules allow egress to the required IP ranges. And verify artifact registry permissions and workload identity bindings are correct for image pools specifically. Good. Here's another one. Question 13. GKE image pool failures. Pods are failing with image pool backoff after a registry migration. How would you debug artifact registry permissions, workload identity, image tags, network, and pool secrets? Here's a strong way to approach it. Check kubectl describe pod for the exact error message first. Permission denied versus not found versus network timeout tell very different stories. Then verify the GKE node service account or workload identity bound identity has the artifact registry reader role on the new registry. Confirm the image reference, region, project, repository, tag, was actually updated everywhere it's referenced. Check network connectivity or firewall rules to the new registry endpoint. And verify any image pool secrets are still valid if using a non-GCP registry path. Nice. Let's continue. That wraps up this episode. Nice work practicing, and see you in the next one.